This video presents the optimization of the Cascade control system. The procedure is very similar to the procedure which was described for the single loop control. Namely, again, we use a main MATLAB program, then we use a function which describes criterion function, and of course we use the Simulink scheme. In the Simulink scheme we have the main controller, we have the auxiliary controller, we have the model of the process, and this part is the part for the calculation of criterion function. The criterion function is as before. This is integral time average error, so we integrate from 0 to 100 the product t and absolute value of the error. If we want to configure this scheme for cascade control, we must make the auxiliary loop active. Therefore, we select the parameter auxiliary loop to the value 1. Then we also will define this gain. This is the gain of the P controller of the auxiliary loop to 2. If we select the gain of the P controller to the value 2, this means that we will improve the speed of this part of the process. Namely, the time constant of this part is 5 minutes. But introducing the auxiliary loop and this gain 2, the calculation shows that then the time constant is 2.5. That means that this part is somehow 2 times faster as it was before introducing the auxiliary loop. The feed-forward compensation is still not active, so we select KPZ equals 0. Let's go now to the main program. In the main program, we define the gain of the auxiliary controller to the value 2. This means that feed-forward control is not active. We select the reference signal equals 1 and we select the disturbance equals 0. Now I will start the optimization. The optimization has just finished. Let's go back to the beginning of this display values. We can notice that the initial value of the criterion function is 88. Then after 45 iterations, we obtain the value 24. And these are the optimal values of the controller parameters: P controller, I controller, and D controller. And this is again the minimal value of the criterion function. And these are results of this optimization procedure. We can see two curves in this window. The blue one is the response with the parameters before optimization. That means when we use parameters obtained with Ziegler-Nichols rules for single loop control, and these are optimal values for the cascade control. We can of course see the big improvement. We can show the value of the overshoot. The overshoot before optimization is, we can see, 34%. and the overshoot after optimization is about 10%. That means the optimization gives us a big improvement of control behavior. The previous optimization was developed for reference tracking mode. So this means the reference was active and the disturbance was 0. In this presentation, we will describe the optimization for the disturbance rejection mode. So we shall put the value of disturbance 0.5 and we shall put the reference value to 0. So I will edit this part of the program. Reference is 0 and the disturbance is 0.5. This is everything what has to be changed. Now I run the optimization. So let's see the results. At the beginning, the value of criterion function was 16, but after 50 iterations, it becomes 2.3. And we obtain also the optimal parameters for P, I, and D controller, and we obtain the minimal value of the criterion function 2.3. The program also gives us a plot. This is the comparison of the disturbance rejection for the basic Ziegler-Nichols parameters for single loop control, and these are results how disturbance is eliminated in Cascade control system. We can notice the big difference. This maximal value here is approximately 0.1 and this maximal value is approximately 0.03. This means that at least it is 3 times smaller in the case of Cascade control. So what are final results of this optimization? This can be presented with this table. So for the reference tracking mode, we obtain these 3 parameters for KP, TI, and TD. The initial value of the criterion function was 88, the optimal minimal or final value 24. For the disturbance rejection mode, we obtain parameters for the P, I, and D part of the controller. The initial value of the criterion was 16 and the final value was 2.3.